Hello viewers, today I want to discuss the part 2 of exponential series. Now the part 2 of this series is talking about complex exponential equations, and I've given out the steps, and we'll use this equation here for an illustration. Now for this illustration we have the steps. Number 1 says identify a common base. Just like the simple exponential equations, the step 1 also says identify a common base. But identifying a common base in this one will be a little bit different from that. Now, how do I mean? To identify a common base, you first need to locate places where we have this exponent, which is a variable. Anywhere you have exponents which are variables, just like x here and x here, you know that is where you want to work on. Now, in order for us to be able to work on that, we need to make sure to get that common base will be the simplest value which it can be expressed to. Now, 2 raised to the power x is the simplest value in which it can be expressed to. But 6 raised to the power x can be expressed as 3 multiplied by 2 raised to the power the simplest value it can be expressed in, which is 2 raised to the power x. Now if we solve for this in this equation, we will have 2 raised to the power x plus 3 open bracket 2 raised to the power x, which is the same thing as 3 multiplied by 2 raised to the power x, minus 32 will be equal to 0. Now this is the step 1. In order to know what to do in this step 2, let us read out what it says. Now it says convert the exponential equation to a simple algebraic equation. To a suitable algebraic equation, sorry. Now what do they mean by simple algebraic equation? In this case, this equation will be turned to a simple algebraic equation. But in other case, it depends. Your question from exponential equation can move into a simple equation, can move into a quadratic or a polynomial equation. But like I said, in this case, it's going to move into a simple algebraic equation. How? Remember our common base. We need to make a law which will be that common base equal to another variable, let's say a. Now we have made a law here. So what we'll do is to substitute what we said it should be inside this equation, which will be a for this plus 3 open brackets a minus 32 equals 0. So let's simplify, which will be a plus 3a minus 32 equals 0. Now the step 3 says simplify. Now what are we simplifying? We're simplifying this algebraic equation. In order to simplify them, we need to bring out these ones, the a's, to one side and collect like terms. Now this will be 4a equals, now when minus moves to this place, it becomes positive. Now this will be plus 32. Now the 0 is not needed. So all we simply need to do is to divide through by the coefficient of a, which will be 4. Now 4 cancels 4. So a will be equal to 4 here 1. 4 in this will be 8. Then which will be 8. A will be equal to 8. But we are not done, because we still have a final step, which is step 4. And step 4 says find the value for the original variable. If you notice, a is not the original variable. From the question, we were originally told to find the value of x. But we end up finding the value of a. Now, how will we find the value of x? Simple. just bring out our former relationship and say, remember that 2 raised to the power x equals a, and substitute the value for a. So when a equals to 4, let's find the value of x, which will be 2 raised to the power x equals 4. Now this is already a simple exponential equation. Now for the simple exponential equation, if you don't know how to solve it, please watch the part 1 of this series. Now this will be 2 raised to the power x equals 2 raised to the power 2. Now cancel this, we'll end up with x equals to 2. And that is how you find the value for your complex exponential equation. Thank you.